Well, as Joanna says, I'm professor at Universidad de Santander in the northeast city of Bucaramanga in Colombia. And my background formation is in aerospace and astronomy. My formation was in France, where I had the opportunity to be part of many scientific projects in space, mainly in Earth observation projects and other solar system exploration and telescopes. So the main part, the first part of my presentation is focused to show you this experience, and the main part of the presentation is the second part, that is the research at my university. We are working with the students and in undergraduate students and graduate students. So let me explain you a little bit of this timeline in my life, where I've been part of these huge space missions from ESA, European Space Agency, the small satellite that orbits our planet Earth and looking for salinity in the waters and moistures in the soils in order to produce high quality models of the climatology in our planet. The second one is it was the Bepi-Colombo mission to the Mercury planet. I developed the mainly cameras of this scientific proof. And the last mission that I worked for ESA was the Euclid telescope, where I've been part of the development of the main instrument of this space telescope. These opportunities teach me a lot of the space sciences and also of the astronomy and astrophysics research. And I had the opportunity to be part of the main laboratories in Europe, and we have developed this kind of instruments. Is the scientific instrument from Bepi-Colombo, Symbiosis. Symbiosis actually is three components, three cameras, a high resolution camera and in the visible, and high resolution also, but with two channels camera in order to reconstruct the surface terrain model, and an spectrometer in visible and near infrared spectrum. So with this kind of complex system, we observe other planets, other surface of the planets, and we can define the composition at the pixel level of each of the components of the surface of the planets in order to study this surface geology and the interaction with the interior of the planet. This was the last vision of the instrument, was what is integrated in the satellite before delivery to the ESA space agency. And this is part of the scientific team that I was there with the French and Italian collaboration. And we had tested and delivered the instrument to the ESA, and it was launched in October 1st in 2021. And after that, after this experience, I came back to Colombia in order to teach at the university. And Colombia has a very big surface, almost the same surface of waters and the same surface of the ground soil. So there is a lot of terrain in order to observe and protect. And we are working in our university in order to make developments and research in Earth observation from space with many different kind of platforms, and with a scientific interest, mainly on forest protection and contamination, study contamination components in our atmosphere. This is my city, Bucaramanga. And Bucaramanga is a sunny city that sometimes looks like this. And this is the air that we breathe, actually. and we don't know what kind of components it has. So in the other hand, this is one of the Colombian rainforests, and we have almost the half of the surface of our country is a forest. But unfortunately, we lost the forest by deforestation very quickly. Almost 3 times the surface of the New York City, we are lost it by year in the Amazonian region in Colombia. That is really, really a big problem for us. And after the peace agreements, deforestation in protected areas, the conflict, started to skyrocket, to go up and grow every year, but we don't have many information, enough information in order to define how to take actions to correct this problem. So in my university, I'm head of the research group CEMOS and head of the research group in Aerospace group in SCUA. And this is all communications and platforms. And we are focused in 3 lines: research, education, and outreach activities. This is all the image of the participation of me and my students in different contests, scientific events, and outreach activities. The education are focused with my bachelor students and master students, and this year we will have the first PhD student. And actually, we are almost 40 students. We're 15 women and seven postgraduate students. And I work with 5 other professors in my university from different engineer programs, and actually from the old university. Even we have students from the human science faculties, and the main part of the groups are mechanical engineer students and electronics engineer students. And we started in 2016 like this, very small group of 5 enthusiast students, and one he was at the epoch was a master's degree student. And we started to be more and more each year. And we started with these little rockets, candy rockets, that we developed by ourselves. And each year, they came more and more students interested in these areas in my university. And we started to go out and speak with people from the other universities and the city, and making outreach activities in our city. And last year, for example, we have 50 new members. So we had double the size of the group in just 1 year. And this because we also do this kind of outreach activities, like rocketry contest at the university level and the high school level in my city, in Bucaramanga. And we participate also in national contests. And my students, they have the opportunity to compete with another engineering students in Colombia, promoted by scientific collaborations with another universities. And this is very important because they learn by projects, and they develop their own instruments and their own developments, and they learn a lot. And our students demonstrate their capabilities winning competitions. And last year, this was the Latin American Space Challenge in Brazil, where we won the international contest, the first place on the pocket Kansas place, and the first place in satellites. And we have the 4th place of the competition with the Orion rocket that you can see in the pictures. And we had also won another international contest from NASA, the Deep Space Food Challenge. In 2021, we won the international contest, and we have developed an growth cabinet for food for us astronauts, and we are interested in develop this new kind of experiments from the micro simulate laboratories in order to simulate the space habitats. And this is an important area that has grown up in Colombia in the recent years. And the other part of the research that we were working are in the ballooning, the drones, CANSATs, high power rotary satellites, and human exploration. As I said, the Earth observation is the main goal, the main research line in these three kinds of parts, subsystems: the platforms, as the rockets, balloon, and satellites, the scientific instruments, and all the related with the telecommunications with this different kinds of platforms. In rocketry, we started with these really sample rockets, candy rockets, that made us to learn the basics of the aerospace engineering and to get fun also, and to get my students involved in this kind of research. They learn to research by doing by themselves. The Orion rocket is our last design, is a high-power rocket that reached 3 kilometers in the atmosphere. And this is the first model, and this was the rocket that we launched in Brazil. Unfortunately, the rocket has exploded after the launch, but this year we want to came back to Brazil and compete again with a corrected version of rocket. But it was a really important experience for us. The rocket has also inside has a CANSAT. This CANSAT has these kinds of wings emulating the birds, and inside the CANSAT we have the different atmosphere sensors in order to study the air quality. And the CANSAT performs this kind of flight in a spiral, and we provide to take measurements of the atmosphere during the flight. Another line is the scientific ballooning. We are working also in development of scientific balloon proofs, also in order to study the atmosphere with our own instruments. We are working on this kind of project. We will launch this balloon from a city called Barranca Bermeja that is near to Bucaramanga. And we are testing this balloon proof in our university laboratories. And we are building this kind of instrument in order to measure the carbon dioxide in the atmosphere, study the concentration with a laser, diode laser spectroscopy technique that is very important. And we are almost in the final stage of the construction of this instrument. And the main part of our research are now focused in the satellite. We are, since 2018, we are working together with Colombian Air Force and the universities of Universidad del Valle and Universidad Sergio Boleda. This kind of project that we are working on is in order to make this CubeSat project 3 units that is proprietary of the Colombian Air Force. And they have this satellite in the Cali facilities. And we are working in order to develop this scientific mission. And at our university, we are responsible of the payload development. This is a picture of the scientific people involved in the project. And we are working as a payload, an hyperspectral camera, in order to observe Colombia from space. and we have done the orbit. We have defined the sun-synchronous orbit for this mission with 2 passes per day over Colombian territory. And the payload is composed by this camera that is also our own design. It's a camera composed by a telescope and a diffractive segment. And all the electronics, the detector and electronics is in the back side of the camera. And we want this kind of image, take this this kind of hyperspectral image in order to have all the spectra of the surface of Colombia, in order to identify deforestation mainly, and other activities in agriculture also. This is more technical, is the internal architecture of the hyperspectral camera, but it's just to say that it has a main part of the optics and a detector, and the closed electronic, internal electronic of the camera connected to the onboard computer of the satellite. And this is the optical design that we have recently published in a scientific article. And this is how it looks, our camera, this part of inside of the satellite once it's integrated. So it's very small because this is a 3 units satellite. And in 1.5 units, we have the space to put all the camera and the electronics. So now we have this first version, and we are testing at the Colombian Air Force facilities in Cali. This is a picture of the different test activities of the electronics. And we have, this is the satellite, and all the engineers are now validated the correct function of the satellite. And we are also develop some kind of projects, master degree projects also, and undergrads, in order to develop space antennas. This is a design of us for this mission. It's a patch antenna to send the image to the ground station that we have also building our own ground stations. And finally, this is where I am now, in the Antarctic region, in the continent of the Antarctica, being part of the 9 Colombian scientific expedition to Antarctic from the Programa Antártico Colombiano. And this is pictures from yesterday. We are here at the O'Higgins Antarctic stations in the Antarctic Peninsula, and working with Chilean colleagues in order to study this site, to build a radio observatory for the EHT telescope, and for a telescope that we are working on developing also in Colombia in collaboration with another professors from UIS University and Universidad Antioquia University, has Germán Chaparro professor and Oscar Restrepo professor in Universidad de Chile, and other professors in Chile also, in Universidad de la Santísima Concepción de Chile. So I'm just finished here my presentation. Thank you so much. This is my contacts, my email, and all social media. So please, if you are interested in this kind of projects, just take contact and let's talk later. Thank you so much.